The retinal circulation, or the blood vessels, is very much like an irrigation system in a large garden. There will be patches where there's a tropical garden, for example, where you'll have sprinklers and misters. There'll be an arid zone where you'll just have fine dripping irrigation, and you'll have a large lawn with sprinklers just to cover the whole lawn. In the garden, you have a head gardener maybe adjusting all of these so that every part of the garden is looked after perfectly and given the right amount of water. The retinal circulation is very similar to this, and the difference being that it's the lining of the blood vessels that does the job of the head gardener. The lining of the blood vessels, called the endothelium, controls how much blood goes through the blood vessels, how fast it goes through there, how much leaks out, how much comes back in, what's delivered to the retina and what's removed. So if there's if there's ever any damage done to the endothelium, the lining of the blood vessels, it affects the circulation significantly. In diabetes, when the sugar goes high, it damages. In diabetes, when the sugar level goes up, the sugar sticks to the lining of the blood vessels and it begins to stop it from working properly. And that's how it causes its harm. Every time the sugar goes up, a little bit of every time the sugar goes up, a little bit of sugar, glucose, sticks to the lining. And if you have a persistently high sugar level, higher than it should be, then you get more damage. And it's a cumulative effect, it adds up over the years. The result of this is that because any pipe can only do one of three things, and the same applies to blood vessels and pipes can burst, bleeding, they can get blocked, which is obvious, and they can leak. The same three things happen in the retina. This is why it's very important to get good blood sugar control. It's actually equally as important to get good blood pressure control. Going back to the example of the irrigation system, if there are problems with some of the pipes and sprinklers or drippers, and you go to the mains and open up the tap fully, you'll end up with the pressure increasing, and anything that was going to go wrong probably will go wrong. The same applies to the blood pressure in people who are diabetic. If the blood pressure is even slightly higher than it should be, more damage is done. Generally, the problem with diabetic retinopathy is that people don't realize there's a problem until sometimes it's too late. Because of the way each part of the retina is supplied by just a single blood vessel peripherally around the edge, it's not uncommon for quite a lot of damage from the diabetes, like blockage, for example, of blood vessels happening out around the edge, and people just have no idea about it, simply because they're using their macula to see what's around them. If these areas of blockage increase, so you end up with a large patch that's not got enough oxygen, it's very similar to a sprinkler on the lawn being blocked. You see that most of the lawn's green, but there's that one part where the sprinkler's blocked, where the grass begins to die and go brown. By seeing the brown grass, you know there's a problem. You know you need to go and fix the sprinkler. In the same way, if there are patches of the retina that aren't getting enough oxygen, the retina produces a chemical, a signal, to make new blood vessels grow. And this signal is called vascular endothelial growth factor, or VEGF. It's a very good idea and it works very well in most of the body. The problem with the eye, though, is that with the lens at the front and the retina lining, if each part of the retina here produces the vascular endothelial growth factor, it leaks into the vitreous, into the jelly. And what that means is that instead of the blood vessels growing into the retina, they grow towards where the vascular endothelial growth factor is most concentrated. They grow into the jelly itself. These are called new vessels. If they occur at the back at the nerve, they're called new vessels at the disc. If they occur anywhere else, they're called new vessels elsewhere. The problem with new vessels is that they sit and float within the jelly, within the vitreous. And as we move our eyes, the blood vessels move one way and then the other. It's a little bit like seaweed under the water at the beach. As the wave goes in and out, the seaweed moves. But every now and then, as you know, there will be a large wave or something will happen and it will tear the seaweed. And the same thing happens with these blood vessels. If you get a tear in the blood vessels, blood bleeds, leaks out, hemorrhages into the jelly within the eye, and then just sometimes can just sit there. Often that blood will go away, but it just sometimes remains there. This can be quite significant visually and can actually mean that people can suddenly lose vision in one eye. This is called proliferative diabetic retinopathy because the proliferative part refers to the growth of new blood vessels. Less severe is non-proliferative diabetic retinopathy, and that consists of little hemorrhages or in large parts of the retina, but also of leakage. Leakage occurs at the capillary level and often happens at the macula. And the effect of leakage at the macula is that you end up with swelling of the macula that's called macular edema. In diabetics, that's a very common cause of loss of vision, and usually it creeps up on you and isn't necessarily noticed straight away. When examined regularly by an ophthalmologist or a retinal specialist, it's possible to pick up patches of leakage away from the centre before they cause harm. These can be treated either by laser or, in certain circumstances, with injections into the eye.